Okay, this video is going to be a graphical representation of the acetic acid sodium hydroxide titration that we just did. So we had 0 milliliters of sodium hydroxide. We had 10. We had 25. We had 40. We had 50. We had 75. I'm pretty sure. Let me check, make sure. Nope, we did 60. And then we did 75. Okay, so the pH with 0 milliliters was totally dependent on the acetic acid. That was 2.87. 10 milliliters of sodium hydroxide, the pH was 4.14. The pH at 25 milliliters, which was the halfway point, was 4.74. The pH at 40 milliliters was 5.35. The pH when we added 50 milliliters, this was the equivalence point, was 8.72. The pH with 60 milliliters added depended solely on the strong base, so that was 11.96, and then the pH with 75 milliliters was 12.30. Okay, sorry that took a little bit of time. All right, so what we want to do is we want to graphically represent this. So we're going to go to Insert. We want to scatter plot. We want a curve. Okay, so let's go ahead and do a title. This was acetic acid titration with sodium hydroxide. pH was our y-axis, and then x-axis was volume of sodium hydroxide added, and that was in, sorry, milliliters. Okay, so let's make this a little bit bigger. And let's scrunch it. Okay, now in your textbook, this is going to be a much sharper rise. So if you think about what I showed you last time with, you know, kind of the perfect picture. I don't know where my mouse is. Just a minute. Okay, so like a textbook, well, that was a really straight line. Let's try again. A textbook diagram of this would be more kind of long and then sharp and up. So I want you to be able to see both. Okay, so just like we did before, we want to look at this real sharp rise in pH, and we want to look at the middle of it. So that would be right here. You know, if I were doing it from this diagram, it would be right here. And what I want you to notice is that here's 7. So that's the pH for a neutral titration, but here is the weak acid, strong base. And notice that that equivalence point is above 7. So when you have a titration of weak acid with a strong base, the strong base is going to cause the, actually the strong base doesn't do it, the conjugate base does it, but that's why the pH is basic at the equivalence point. What I want you to notice here is this region. There's this real long, kind of not much change in pH. That's a region of maximum buffering. So this is where your buffer is doing its work. It's not allowing pH to change much, despite the fact that you're adding sodium hydroxide. And then there's going to be a point where the buffer capacity has been reached and it can't take any more of that strong base, and then pH is going to start to rise. The other thing to notice here is this point here, where it kind of starts to level off, top of the curve. That's where you've got excess base. And so at that point, you're not going to see a lot of difference, not a lot of change in pH. It's just going to level off slightly. So those are the important parts of the curve that you want to notice. The other thing that I want you to notice between this and the graph that we did before, if you remember, it would probably be better if I had both graphs here, but I don't. So let's just do it this way. Here's your strong acid, strong base, kind of exaggerated. Here's your weak acid, strong base. Whoops, and it disappeared. Let's see if I can go back. No, never mind. All right, guys, I'm sorry you have to listen to me talk to myself. The way you're going to distinguish between a strong strong and a weak strong is with a strong strong, there's not a large region of buffering. Here with the weak strong there is. With the strong strong, that kind of starts changing pretty quick and then goes up. In all of the titration curves, equivalence point is at the middle of that really sharp rise, doesn't matter which. With a strong titration, the pH at the equivalence point is going to be 7. With a weak acid, strong base, your pH at the equivalence point is going to be above a pH of 7. And then I'm going to do another video later, which you do not need to watch for your notes, but you can watch for reference, where we will do a weak base. So pH will start high, region of maximum buffering. So here, pH at the equivalence point there, because it's got a strong acid with a weak base, is going to be below a pH of 7. But I'm going to do this in another set of videos. So in terms of what do we want to do with indicators, with this one, we're going to want to pick an indicator that's going to change color kind of close to the equivalence point. With the strong acid, weak base, we want to pick a different indicator that's going to change color close to an acidic pH point. And there is a table in your book where you can look at the color ranges and the pH ranges for indicators, and you'll be introduced to that in your lab this week.